We now determine the general solution of this second order non-homogeneous differential equation. So first we have to determine the general solution of the homogeneous equation. For this we set the left side of this equation to 0, that is 6y double prime minus y prime minus y, and this equals 0. So for this we should find the general solution of this homogeneous equation. So we can write the characters equation. Therefore, this can be written as 6y double prime is replaced as r squared minus y prime is replaced as r. This one is replaced as r, and then negative y is replaced as negative 1, and this equals 0. So we have to solve this equation, characters equation in r, and determine the values of r. So let's put this in factor form. Here we see that the middle term, which is negative 1, the, the sum is negative 1, and the product is 6 times of negative 1, which is negative 6. So we should basically split the middle term such that the sum is negative 1, and then the product is negative 6. So let's say if we have negative 3 and positive 2, the product will be negative 6 and the sum will be negative 1. So basically we are going to split this middle term as negative 3r plus 2r. And so therefore we can write this as 6r squared negative 3r plus 2r, and then we put this negative 1 and this equals 0. Now we can write this in factor form. Let's consider these two terms, and here we can factor 3r, and so when we do this we get 2r minus 1. Now let's consider these two terms. Here we simply factor 1, and when we do that we get 2r minus 1, and this equals 0. Now looking at this equation, we have 2r minus 1 here as well as 2r minus 1. So this can be factored out. So therefore it is 2r minus 1. And you factor 2r minus 1, here it will be 3r, and here it will be positive 1. So basically we have written this quadratic equation in R in product form as this. We just put this little bit closer. So we can solve for R by using the zero product property, that is 2r minus 1 equals 0, or 3r plus 1 equals 0. And solving for r gives r equals half, and solving for r here, r is negative 1/3. Let's say this is r1 and this is r2. So we have obtained two values for r. Now we can write the homogeneous solution. Let's write this as yh, and this is given by a e power r1x, that is half x, plus b, which is constant, e power r2x, which is negative 1/3 x. So in the first step we have determined the general solution to the homogeneous equation, that is yh equals a e power half x plus b e power negative 1/3 x. In step 2, we write the general form of the particular solution. That is, we should write y sub p using this right side expression. The general form of this one is a e power half x. This is for an exponential function, but we can use the letter c because we have already used the letter a, b for the constant. So here I'm going to use c. But since this term is already present in the homogeneous solution, that is here we have e power half x already, so we should multiply this by x. This has to be multiplied by x, and so we can write the particular general form of the particular solution is cx times e power half x. In step 3, we should find the derivatives of the particular solution equation, which we obtain in step 2. So here we have this yp equals cx e raised to the power of half x. And since this is a second order, we should find two derivatives of this yp equation. So let me copy the yp equation. This equals cx e power half x. Now let's find the first derivative by differentiating this equation with respect to x, that is yp prime. And this equals, here we apply the product rule considering the cx as the first term and e power half x as the second term. So in product rule, we consider one of the terms as the first one, which we write down, and then multiply with the derivative of the second term. The derivative of e power half x is e power half x, and then applying the chain rule to find the derivative of half x, which is half. Now we put plus and then we write the second term, which is e power half x. Multiply this with the derivative of cx, which is c. Now let's put this in simple form. So here we have yp prime, and this equals, we put this front, that is cx times half is cx by 2, and this is multiplied with e power half x. We then have c times of e power half x. Now I'm going to factor this e power half x, which is present in both terms, so that we can write this in factor form. So we have yp prime, and this equals e power half x. And when we factor e power half x, in fact, we can factor the c e power half x. So let me put the c also here. And when we factor the c e power half x, the first term we are left with x by 2, and in the second term we are left with 1. So this is the simple form of yp prime. Now we should also find its second derivative, since we need this, uh, that we can substitute in this differential equation. So let's find the second derivative of yp prime. That is, we differentiate this one more time. So I write yp double prime, and this equals, once again we can use the product rule. So let's consider this as first term and this as a second term. So I write the first term, that is c e power half x, and this is multiplied with the derivative of x by 2 plus 1, which is 1 by 2. Now I write the second term, which is x by 2 plus 1, and this has to be multiplied with the derivative of the c e power half x, which is c e power half x, and then multiply this with the derivative of half x, which is half. That is, we apply the chain rule when we differentiate e power half x. Now let's put this in simple form. This one is yp double prime, and this equals, when we can multiply the c with 1 by 2, which is c by 2 e power half x, plus here we will have c times 1 by 2, which I write this as c by 2 times x by 2 plus 1 times e power half x. The next step, we see that we can factor this expression, that is c by 2 e power half x, and in the second expression also we have the product of c by 2, this one with e power half x. So I'm going to factor that. So therefore I write yp double prime, and this equals, factoring out c by 2 e power half x. From the first term, if I factor this one, it will be left with 1, plus I factor this term as well as this term. So then I'll be left only with this expression, that is x by 2 plus 1. So here I put x by 2 plus 1. Notice that we can simplify this expression inside the bracket by adding this 1 with 1, which gives 2. So it is basically x by 2 plus 2. So let me just remove this and rewrite this as, we have x by 2 plus 2. So we have written this yp double prime in factor form. In step 4, we are going to determine the value of constant c. First, I'm going to rewrite this original differential equation by replacing y as yp. So this will become 6 times of yp double prime minus y sub p prime minus y sub p, and this equals 4e power half x. Now we are going to replace yp prime and yp double prime as we have found from step 3. So this implies 6 times of replace yp double prime by this expression. So this will be c by 2 e power half x, then multiplied with x by 2. We then have negative yp prime. So negative of replace yp prime now. This will be c e power half x multiplied with x by 2 plus 1. Then we put a negative of yp. So this is negative cx e power half x. And on the right side, we have 4 e power half x. So basically, we have to simplify this equation on the left side and then equate the term e power half x so that we determine the value of constant c. So first, let's simplify this. Here we have 6 times of this product. So we can easily cancel the 6 with the 2, and this goes 3 times. So 3 times c is 3c. So it's just 3c e power half x times x plus 2. And this one is a negative of c e power half x times x by 2 plus 1. And now I write this term. So this one is negative cx e power half x. And on the right side, we have 4 e power half x. Now let's divide each terms both on the left side as plus on the right side by e power half x, because we have e power half x in both sides of the equation. So divide by e power half x so that we can make this equation little simple. So this first term will be 3c times x plus 2 minus the second term will be c times of x by 2 plus 1, and third term will be minus cx, and this equals on the right side we will be left with only 4. Now let's simplify this and solve for c. Let's distribute this first. This equals 3cx. 3c times 2 is 6c, and this one is negative cx by 2, then negative c, negative cx, and this equals 4. Okay, I observed that I have made a mistake when copying this yp double prime. So yp double prime, this involves x by 2, but here I have written as x. So I'm going to change this to x by 2. So this will be replaced as x by 2. And so therefore this is x by 2. And so when you distribute this, this will be 3cx by 2. Let's simplify this. And so this gives, this one is 6c minus c. We can, this one is a 5c. So first I put this 3cx by 2. Then I write this negative cx by 2. I then write this negative cx. And this 6c minus c is 5c. So I put 5c, and this equals 4. Now let's multiply all the terms by 2 so that we can remove the fraction. So therefore this will be 3cx minus cx minus 2cx. This will be 5c times 2 is 10c. This equals 4 times 2 is 8. So this gives negative cx, negative 2cx is negative 3cx, and negative 3cx plus positive 3cx is 0. And so we are left with only 10c on the left side, and this equals 8. So solving for c, we get c equals 8 by 10, or otherwise this is 4 fifth. So we have determined the value of c equals 4 fifth. And so now in the final step, that is in step 5, we write the general solution. That is y general solution, y sub p equals the homogeneous solution plus the particular solution. And so this equals, we take the homogeneous solution from equation 1, or from step 1, which is a e power half x plus b e power negative 1/3 x. So here we write a e power half x plus b e power negative 1/3 x. And then we write the particular solution by replacing c equals 4 fifth. So we take this particular solution either from 2 or 3, which is cx e power half x, cx e power of x. We replace c by 4 by 5. So it's 4 by 5x e power half x. And this is the general solution to the given homogeneous uh, different I'm sorry, it is a non-homogeneous differential equation. This is the general solution.